Welcome to the lecture on principle of sealed arc welding processes. So, now we will discuss about the principles of the arc welding process where the shielding is done. In any arc welding process the shielding is done. Now that shielding, how that shielding has to be done, that is decided in different way. So, first of all, what we see is that when we talk about the arc welding, then there is some term like arc. So, this arc has to be maintained between the electrode and the workpiece, or sometimes we also produce the arc between two electrodes, and then that arc has a quite high temperature, and that is used to join the pieces or fuse the metal in a particular domain. So, that is how this arc welding is defined. So, in that we produce the arc, and then since the arc is at a very high temperature, so that molten pool which is formed, that needs to be protected from the atmospheric contamination, especially from the gases like oxygen or nitrogen, which may dissolve into the pool, which may dissolve into the metal and form the undesirable phases, and they may spoil the weld itself. So, that is how you have the, first of all you have the creation of arc, and then the arc welding processes are classified based on how you are giving the shielding. So, or how you are making the arc. So, first of all the arc is produced by using the electrode. In one case the electrode is the workpiece, and of the two electrodes, one is the electrode which produces the arc, other is the workpiece, or you may produce the arc between two electrodes, and that arc is directly concentrated on the workpiece so that it melts. Then about the shielding, sometimes we use the coating on the electrode. So, in that case this coating material which is over these electrodes, they melt and create an atmosphere around the molten pool. So, they will cover it. So, these are fluxes, basically they also melt, and then they create a blanket of gases on the top surface of the molten weld pool, and this basically is protecting the weld pool. So, that is shielding is done basically. So, that is another mechanism is that you use the gas. So, that gas goes onto that weld pool and that envelops it. So, that way you also shield it. So, based on that you have shielded metal arc welding or gas metal arc welding. So, this way you have SMAW or GMAW or GTAW. When we will talk about all this. So, that is why you have typical welding processes like shielded metal arc welding. You have gas tungsten arc welding, that is TIG. You have metal inert gas welding. You have carbon arc welding, so submerged arc welding, and all that. These are the varieties of arc welding where you create the arc. Like if you talk about the shielded metal arc welding. So, basically in that case you have a flux which is there, and then that flux so normally the electrode is coated with flux, and this is normally a electrode which is normally consumable, and then once it consumes, it is coated with flux. This flux melts and creates one environment around the weld pool. Similarly, you have GTAW, which is gas tungsten arc welding. So, in that what we do is we create the arc with an electrode whose job is only to create arc. It does not get consumed, and the electrode is also bare. So, you use not bare, this is a tungsten electrode, and you feed the material required in a bare form, and the shielding is done by supplying the gas in that, I mean, you have a specially designed torch, so the gas comes, and the gases normally are helium or argon used, and in some cases carbon dioxide also. So, but the tungsten electrode is there to basically create the arc. Similarly, you have metal inert gas welding. So, in that case, what we have here, you have basically the electrode which is consumable, and you have the inert gas which is flowing. So, that way, that is why it is the metal inert gas welding. You have carbon arc welding where the arc is produced by carbon, or submerged arc welding where the arc is submerged in the granular flux. So, this way you have different types of welding processes. Now, we come to the first variety of shielded metal arc welding. This is also known as SMAW. So, what is there in that? Coalescence of metals is produced by heat from electric arc, which is maintained between the tip of a covered electrode and the surface of base metal in the joint being welded. So, that is how the SMAW takes place. Now, here the rod which is there, that basically melts, and that will basically conduct the electric current, and it will conduct the electric current to the arc, and it will also provide, or it will work as the filler material for the joint. So, what happens that the electrode which is connected to the electrode holder, now it has, since it is a metal, it is carrying the current and producing the arc and getting consumed. So, that way you are using that electrode also as the filler material in that case. Now, what we do is that normally this electrode is having the covering, and this covering has many purposes, and basically the main purpose is that it is stabilizing the arc, and also it will be protecting the weld metal from atmosphere because you have many gases who will try to get dissolved into the weld metal pool, and that is how it will spoil the quality of the weld. So, this coating will be decomposing, and then because of the heat of the arc, and then it will provide a blanket of protection to the weld pool. So, what is there in the case of this shielded metal arc welding? If you look at the schematic, so basically you have a AC or DC power source which is there in this case, and what happens that you have this is the electrode, this is the electrode which is connected to electrode holder, and this is a work, this is the work on which the welding is to be carried out. Now, the thing is that the electrode and the workpiece, in between there is arc which is created. So, creation of the arc itself, there is a mechanism by which this arc is created. Now, how this arc is created? So, what happens that the creation of the arc, there are two theories for the creation of this arc. Now, there is ion theory of the arc column. Now, the thing is that you have a positive electrode, you have a negative electrode. So, once you are connecting that to a power supply, now what happens that the ion theory of the arc column tells that you will have the flow of ion from the anode and it will move towards the cathode. So, that is the theory of the ion theory of the arc column. Now, the electron theory of arc column tells that the electrons will basically move from the cathode and it will strike the anode. So, basically you will have the ion theory, because since metals are positive, have mostly positively charged ions. So, they will have affinity towards going to the cathode. So, they will be moving from, so ions will be moving from here to here, whereas this has extra atoms. So, these atoms will be moving from here to this place. Now, what happens that when these ions will move from the anode to the cathode, in that case it will try to ionize the gas column in between. Now, there is the gas column, which is basically air, and that is basically ionized. Now, what we see is that here from the electrons are moving, and they are moving through this gas column, that is in between you have the plasma. Now, from here they are basically coming in between, and there is large amount of electron which are basically coming from the cathode, and these electrons are moving at a high velocity, and they are impinging, they are basically bombarding this anode surface. Now, what happens that because of they are hitting this anode, there is large amount of heat is generated. Now, this what happens, as you see that you have three regions, one is near the cathode, one is near the anode, and in between you have the plasma. Now, basically that also gives a resistance to the flow of these electrons, which is coming from here. Now, the thing is that when we are using this DC power supply, in that case normally what happens that, as we know that these electrons will move from cathode to anode, and the ions will move from anode to cathode. Now, you have three zones, one is near the cathode, one is near the anode, and another is in between the cathode and the anode. Now, this is they are moving at a very high velocity and they are bombarding over it. So, most of the energy that is in the form of heat is liberated at the anode terminal. So, whenever we talk about the DC power system, in that case, since the movement of electron is fixed, it is moving from cathode to anode. So, you will have the movement, I mean you have the stoppage at the anode, and larger section, larger fraction of the heat, that is 2/3 of the heat is generated at the anode. Whereas, if we talk about the AC power system, in that the polarity is changing every cycle. So, you will have the equal amount of heat which is generated at the anode as well as the cathode, and the that is why you have different way you apply. So, in the case of a DC system, basically you can control, or you can see that how much, if the suppose plate which is to be joined is thicker one, you feel that the plate should be heated. So, because then in that case you have to see that the plate should be connected to anode and the electrode should be the cathode, because the plate will be heated more, there will be more generation of heat at the plate, and in that case you can have better penetration in the thicker plates. So, when you have thicker plates, you go for the positive terminal connected to the plate, and this way that is known as straight polarity. So, that is basically you can change it. So, you can change that polarity. So, when you have the DC power source, and when you have electrode negative and work as positive. So, basically larger of the heat is applied or generated at the work, and that is how it is known as DCSP, also DC straight polarity. So, this is a straight polarity. Now, the thing is that if you are changing this direction if you change the electrode, like you make the electrode to positive terminal and the work to negative terminal, in that case it is DCEP. So that is direct current electrode positive, and this is known as also direct current reverse polarity. So in that case what we see is that your maximum heat will be generated at the electrode. So electrode will basically become more heated, it will consume also faster, but normally the penetration is smaller in this case, and that is normally used when you have thinner plates. So in those cases, if you have if you use the straight polarity or electrode negative and work positive, in that case there will be chances of deformation and there will be uneven weld bead structure. So that is why in those cases you go for the reverse polarity, where maximum heat will be generated at the electrode itself. And when we talk about AC systems, in the AC system basically you have change of flow because it goes in a sinusoidal cycle. So you have the flow of current, flow of electron reversed in every cycle. So that way you have equal amount of heat generation at both anode and the cathode. So that way it has the property in between the DCEN and the DCRP. So this way, this is the theory of the arc generation in the case of arc welding. So you have two theories. One is ion theory, which tells that there will be movement of ions, that is positive ions from anode to cathode. Similarly, you have electron theory, which tells that the cathode will emit the electron will come to anode, and that is how you have three basically regions, and the two regions at the one at cathode and one at anode, and more of the heat is at the anode in case of DC power supplies. Now we talk about the process characteristics. Now if we talk about the process characteristics, then first is the principle of operation. Now principle of operation means what is the principle of creation of arc. So that we have already understood that when you are connecting the one of the work and you have electrode. So one is connected to positive power source, another is to negative. In that case the current allows to pass, electrons flow from the cathode to anode. So first of all it is touched, so that way there will be flow of electron, but then you are creating a gap, and in that they try to jump. So that way there will be ionized column development, and in that basically there is large temperature which is achieved, and it goes maybe about 11,000 to around or 10,000 to 11,000 degree Fahrenheit of the temperature, close to 5,500 or so, about degree centigrade of temperature is achieved in that column, and that is high enough to basically melt the material where it is hitting. So that is how you have the basically principle on which the arc is created, and then you go on doing the welding. So that is what we discussed about the principle of arc initiation. Then you have, as we discussed, you have power source selection. So power source selection means you have either the DC power source or you have the AC power source. So you have you can use, depending upon the situation, you can use either go for DC power source or you can go for AC power source. Then you have the arc shielding. Now coating in the electrodes. If you talk about the electrodes which are used, now normally these electrodes are known as stick electrodes. So this is in the form of a stick, and they are basically covered with certain fluxes. Now what happens, that the fluxes which are used, basically you have the electrode like this, and on this you have this way you have the fluxes which will be there, and ultimately at the top you have. So what happens that this is to electrode holder, and from here this is the bare at this point. So once it touches, the flame will start from here. Now being this inner portion as the conductor, so that will melt fast because of the heat, and then what happens, the flux which is coated around it, it has certain functions. Now one of the function is that this basically helps it to direct towards the weld pool or towards the metal where it is the placement of the metal itself, so that otherwise what will happen if there are no flux coatings, then these arcs may be going in all the directions. So there may be large amount of loss of this heat from the arc due to radiation in all the directions. So you will have the proper direction or proper stability of the arc is maintained by these fluxes. Second is that this flux, once they are melted, then they create envelope of gases around the weld pool. So in that case, what we see is that they will be protecting the weld pool from any atmospheric contamination, as long as this sealed coating is getting consumed, and as you are moving for welding, in that case you have the envelope of shielding gas generated, and that basically protects it from the from further contamination of that weld pool, because the temperature is quite high, and at that high temperature there may be chances of atmospheric contamination or dissolution of a lot of gases into the weld pool. Third is that it also acts as, sometimes if you want to reinforce the weld pool with certain alloying elements, you can also use these alloying elements for reinforcing that weld pool with these fluxes. So there are many advantages of these coatings. Arc shielding, already we discussed that the arc is, because of that arc, the flux is able to maintain a covering over the weld metal. You have, we'll discuss about the capabilities. So as we know that it is quite capable, it's quite versatile, very cheap process. So this is one of the mostly used process in the case of arc welding. However, there are certain limitations also. Now the thing is that what are the limitations? So the thing is that when we use the electrode, and since the current passes through the electrode, which has the central core portion is the metal, so because of the resistance it gets heated sometimes, and then the covering may break down, so that may alter the arc characteristics many a times. Then also as we know that the electrodes are to be consumed, they are basically consumed as we move in the welding direction. So at the end you are throwing the unused portions, which it is very smaller, and if you have to start the fresh work, so you have sometimes a wastage of these electrodes. So that wasting is there in that case. Another limitation which is there in the case of this shielded metal arc welding is that as we know that you have the making of flux, and these fluxes at the surface of the weld, top surface of the weld, being lighter also they are at the top surface of the weld. Now that is to be removed in every pass. if you do not remove them, in that case that may create the problems that may be forming undesirable phases that may affect the corrosion resistance property of the material or other mechanical properties. So, these are the limitations of the this process. Now, you have different varieties of arc welding process, and we will discuss about few more. One of them is the submerged arc welding process. Now, in the case of submerged arc welding process, what we see in the case of stick electrodes, what we see is that the blanket is produced by melting of the flux which is on the coated on the electrode itself. Now, in the case of submerged arc welding, what happens that the welding which is going on, now that is basically submerged under the granular flux. The flux which is used is the granular flux. So, you cannot see the arc is not seen. In this case, the arc is completely surrounded by the granular flux, and the flux is continuously supplied. That flux is basically, now the flux which is in contact, so you will have the hoop of the flux, and where the melting takes place anyway, the flux will come in contact, and again the flux will do that purpose of making a blanket of the. So, anyway it is all anyway it is enveloped, and also that flux in that atmosphere, the arc region is completely protected. So, that will be fusible flux, and this because that flux which is completely covered, so it does many purpose, like it will be doing the stability of arc, mechanical and chemical properties of the weld deposit are also improved in this case. Now, in this case, since we are using the granular flux which is there from all the sides, so we are using the bare wire. So, that wire are used, and that basically the holder or the mechanism by which the wire is coming, now that can be moving as the welding progresses, or the work on which the welding is going on, that can move. So, continuously you can, so since it is in the form of wires, bare wires, and they are basically coming through a mechanism by which you can continuously feed the wire. So, that process which is there, I mean there is basically a challenge in the case of shielded metal arc welding, that does not remain here. In this case, the arc can continue for long, and that way you can have very large welding which is possible in the case of submerged arc welding. So, you can see the submerged arc welding here, the deposits can be quite at larger rate depending upon the value of current. You can use larger value of current in these cases. You can have even depending upon the type of deposit or type of penetration, you can have either larger current or the larger or the even the change in the voltage values. Now, as you see that in this case you have, this is a slag. So, this flux will be coming through this hopper, and the arc is created here, and this way the slag will be there on the top surface, and you have the mechanism of using the unused so every time this slag, I mean the flux is there, this flux will be used, and most of the unused flux can further be used. So, this way you have the further use of the slag, I mean fluxes. Now, in this case you have as we know that principle of operation is again somewhat the same, because you have again you have the electrode which is basically the bare wire, and one is the work. So, this way you have the initiation of the arc, then you have different modes of welding. So, in the case of submerged arc welding, you may have the manual or semi-automatic, or you can say machine type of processes. So, how you are able to move, how you are going to give the feed of this wire or bare rod to the machine, how you are controlling in what way, automatic way or semi-automatic way. So, based on that you have different welding methods. You have materials, electrodes and fluxes. So, the materials, any material are weldable, are welded. Electrodes, as we discussed, that electrodes we use the bare electrodes, and you have different fluxes. Preparation of fluxes are different, which are used in this welding method. As we talk about the operating variables, now operating variables are normally here the welding current, which is normally quite larger value is taken depending upon the degree of penetration which can be used. You have voltage also. Voltage, basically if you take larger voltage, it will talk about the flame dispersion. So, it will go and heat in the larger portions. So, that way that is the characteristics of a larger voltage. If you have larger current, the penetration will be more. So, depending upon that, the operating variables can be controlled. Then the next type of welding is also, one is carbon arc welding. Now, in the carbon arc welding, the arc is between the non-consumable type of carbon or graphite electrodes, which are used for heating the work, and then this way either you have the twin carbon arc welding also. So, there are many applications which can be it has many advantages. Now, most of the this process mostly has been replaced with other welding processes like TIG or SAW. Now, in this case, carbon is normally used as a source of heat, because either carbon or graphite is used as the electrode material. And this is the schematic of carbon arc welding, where you have carbon electrode, and this way the arc stream is generated you have, and the weld bead appears like this. So, this is the one of the variety of the arc welding. We will discuss more about the principle of generation of arc, and also about the different processes in the coming lectures. Thank you very much.